So here is what we want to solve an equation, an equation. So, but not an equation, a linear inequation. So it will be in the general form ax plus b less than, let's say, um, so a constant. So instead of doing that, so um, we can just consider the general uh, situation, this one, less than, for example, b. Okay. So the question is how, what are values, possible values of x are satisfying all the possible values that can satisfy in an equation like that. So the idea is to eliminate the constant factor of x so that we can isolate x. So it depends. If you have a positive, so we can divide always by a coefficient a positive. So if a is positive, so I can divide without changing. Uh, so my inequality will be less than b over a. It will be equivalent to that. Okay. Yes, and I will have, so let's say it's not exactly this bar. So I have, yes, let's identify all the possible situation. My equation will be equivalent to x greater than b over a. Okay, if my a is negative, because my a is negative, I need to change the inequality. Now, if a equals 0, so if I have 0, that means I will have 0 then, if a equals 0. So I will have 0 less than b. Okay. I will have, so depending on b is positive, I will have solutions, finite solutions. But if my b is less than or equal 0, I will have no solution. Okay. So this is the three situation how we can, yes, we can have. Okay. So let's do then an example. First example. Okay. Suppose that we are given to solve, okay, solve the inequation 2 minus 2, 9x greater than minus 2. Okay, I don't have exactly this form or an equivalent of this one, changing this sign of inequality, but I can bring myself to this situation. Okay, so group the x's, the terms in x one side, the two constants in one the other side. So the second step of this will be minus 9x. Add minus to both sides, so that they cancel, I will get 0 here, and here I am adding, so it's minus 2 minus 2. Okay, so I will have minus 9 times x greater than minus 4. To isolate x, I need to remove these, eliminate these constants. So we can do it by multiplying both sides by 1 over minus 9, which is negative. So I need then, so it's, or dividing, we say also dividing, but okay. So I will get then uh, by simplifying. So let's do it once here to show what we are doing. X, then since it's negative, this term is negative, so I need to change my inequality. Okay, 1 over minus 9 and times minus 4, which gives me then x is less than 4 over 9. Okay, and this is my set of possible solutions. I can use the line to illustrate, to identify my set. Let's use the rule. Okay, so we will have something like that. So I have a 4 over 9. Let's say 4 over 9 is here, 4 over 9. Then it is strictly, that means I cannot consider 4 over 9, and I will consider all the values less than strictly. So I will have this interval, and I can, in terms using um, the interval notation, my solution set is minus infinity to 4 over 9. Okay, great. So let's do another, explore the following. What if we were asked to find the variable y, so that 3 times y minus 5, okay, again is solved. Maybe I should write, what's better, solve the inequation. So 3 times y minus 5 minus 3 times y plus 6 less than 7. Again, here I need just to work on my expression after developed. So you will have 3y. mm, Okay, so we will have 3 if I develop minus 15 minus 3y minus 18 less than 7. Okay, I see that I can cancel these two terms. Okay, I can cancel them. I choose the color here. They cancel. So finally, I can obtain compute, or even I don't compute. I see that I have then minus 33 less than 7. This statement is always true. So it's always true. That means for any y, from the beginning, if I substitute any value, real value from R, okay, the this inequality will be satisfied. That is, okay, that is the set, my set this time. Look at what we are doing here. That means we are saying the following. We are saying any y I choose here, any this y from will satisfy the inequality. That means I can take all of them. Okay, that is also, we can say that the set of values are minus infinity plus infinity, or the whole set of real numbers using this notation. Okay, great. Let's do then one last example. Solve. So let's do this one here. Solve this inequation. 5 minus 3x minus or equal. So we come here. So here in fact I can read it as two inequations. So I can write, we can do it separately. Say so first method. So let's one method, first method. I can decide, say that this inequation is, let's say number one, is equivalent to this. There's two inequation, 5 minus 3x less than minus 4, and minus 9 over 4 strictly less than 5 minus 3x. So, so that the advantage of this, you can work separately. Okay, you can work separately each inequation like that here. Then consider, because we are working with and, so we need to take the common values. So you need to take the intersection of the two sets. The second method is just starting directly and see what we can do. Let's do it. Second method. So it's not really second method, but maybe the steps are not exactly, maybe, yes. So one will, I can say isolate. So I want to isolate x. So I can, for inequality, add the same quantity or subtract it without affecting the result. So I will add minus 5 so that I eliminate 5. Okay, so that's 5 minus 5 minus 3x less than minus 4 minus 5. So that I have minus 3x between minus 9 or equal, and here minus 29 over 4. Then I need to eliminate minus 3. So that means I divide by something, but then when I divide, I need to change the inequality. Okay, so here I prefer to separate. I prefer to separate like I suggested above. So I will say I need minus 3x, okay, less than minus 9 and minus 229 over 4 less than strictly minus 3. Okay, so then let's solve each equation. So the first one will, if I divide by minus 3, I will get x greater or equal minus 9 over minus 3. And you see this and is very important. I forgot an x here. So if I divide both sides, also I will change the inequality. So I will have 29 over 12 greater than x. Finally, I have to consider those two sets. So let's see what we can get with our sets here. So I have a line here. Let's put it here. Okay, so I have the value 3 here. And here 29 over 12 is smaller than 3. I need to consider first the first set x greater or equal 3. That means I am here. This is my set x greater or equal 3. What about the other one? The other one is this one. Let's change another, take another color. X is less than strictly exclude this value and take the values that are strictly less. So this is x less than 29 over 12. But now I need the common points. So be careful here. We have and we need the common points to the two sets. Is there any common point between the two? No, there is no common point. No common point. Okay, that satisfies both the equalities. That means that satisfies the original two inequalities. That is the set of solution here is the empty set.